Welcome to the Data and Ethics session. We're really excited to have a panel discussion followed by, we hope, a really vigorous Q&A session. We have today, we have Jarrett Zygon, who's an anthropologist, Phil Boyce, a lawyer, and me, an economist. I'm Stephanie Shipp. Take a guess at which one's the lawyer and which one's the anthropologist and ethicist on the stage. When I introduce ourselves, it makes it sound so neat and tidy. We each have our different views from our different disciplines. But as you will see, I think that there is a lot of overlap, but a lot of unique perspectives as well. Jarrett's interest includes anthropology of moralities and ethics, the intertwinings of humans, worlds, and situations, political activity and theory, and much more. Phil is a lawyer, and he's working at the operational level in data science-driven medical research, and his interest is to develop workable legal solutions that preserve the rights of individuals, serve the public good, and allow data science in medicine to flourish. And my interest is to embed ethics into data science through the entire life cycle of data science, and to address whether implicit biases exist, and if they do, how do you minimize them or eliminate them? So our interests intersect in that we are all working toward the same goal, which is to advance the social good through ethical research. So the order of our speakers will be Jarrett, followed by myself, and then Phil. I'm sorry, I keep reversing this. We've gone back and forth. The order is Phil, and this is really important back here. Myself, I'm still in the middle, and Jarrett, I apologize. We've gone back and forth on this through multiple discussions. Right.
Just so you know, I'm not just checking my Facebook status. I'm actually setting a stopwatch because I'm serious about not going too far. We have a lot to cover, and let's see, do we have, excellent. So yes, I work at the Center for Diabetes Technology. I am in fact a lawyer, but the things that I want to talk to you today are not particularly lofty. I'm coming to you from the front lines of data science, where it's actually being implemented. We have a couple graduate students back here who are working on these projects. One of the things that we do at our center is the artificial pancreas. This is a small device with control algorithms that delivers insulin to type 1 diabetics. This is a smart device. It's a combination of white box, black box techniques, according to these gentlemen back here. And I don't actually know what that means. I sort of do, but this stops people from dying. That's what this does. And in our world, data science is not particularly theoretical. It is about something that goes from an idea, oftentimes to a device that can be deployed, implemented very, very quickly, considering how long it takes for a drug to be developed. So our work is engineering in many ways, and one of the things that I do is to stay out in front and make sure that we are getting the data rights, the data use rights, and access to data that our scientists need to keep going. Data is the raw material that makes this all happen. It's the oil, it's the steel, it's whatever runs the factory, and without it, we're done. So what I'd like to talk to you today is very quickly about this fourth paradigm that Victoria mentioned. I'm really glad she did, because that fourth paradigm in the scientific method has also thrown a monkey wrench in the usual way that we do business legally. And I'm going to show you some examples real quickly. All right, so we're really talking about a supply chain issue in my world. How do we get data, and how are we using it? Core concept. I don't know if most of you are data scientists or where you fit into this world, but one of the basic concepts here is that data scientists usually do not generate their own data. You might be working in collaboration with scientists where you are in a funded study that is collecting the data, but more often than not, that is not the case. You're repurposing existing data. So, easy thing to say, and what this means is somebody has to go get that data. That's me. Yeah, so I'm going to give you an example, just so that this is not theoretical. I'm going to put all my slides out. All right. I've worked on the CIF PriMed project, which relates to treatment and cure and management of type 1 diabetes. One of the projects that we've been working on is to create this thing in the center here, a physiomic database. And that database is intended to be comprised of a bunch of little data sets of blood glucose readings mostly. And our wizards are going to take that, compile it till it is a size that's appropriate for the techniques that they use, and then use it to create new projects. Those projects include in silico models, which I personally find to be the coolest thing ever. There's an in silico model that is so accurate that it's FDA approved of the functioning of a human pancreas. You can use predictive analytics. I mean, if I'd start talking about this and we'd be here forever. All this cool stuff comes out of that data set in the middle. So the question is, how do we make it? In this case, I've represented 10 clinical trials. All of those in this hypothetical are NIH-funded clinical trials. They are subject to the NIH data sharing policy. It is possible for us to go out and take that data from those studies. Understand that those studies were probably done to study the efficacy of a drug. The blood glucose values that we're taking were not the purpose of the study. It's a byproduct of the study. And our guys are going to be taking it, repurposing, and making all this cool stuff. The question is, how do we get it? We use contracts. The speaker this morning was talking about the reluctance of people to share tools, similar reluctance to share data, even though NIH requires it, whole other talk. So let's just stop and appreciate the magnitude for the strategic purposes of this university and all of data science. Last year, $26 billion and 47,000 studies were conducted and funded by NIH. That means all of it is subject to the data sharing policy. That is an enormous public resource. God only knows what these guys could do with that with a couple months or a couple years and a whole lot of pizzas. Our cost to get that data is zero. Think about that. You're going to start a business and your raw material costs nothing. That's what we're facing right here. All these data scientists in this room, that's what you get to work with. Usually you have to fund a study and collect it yourself and spend the money to collect it. How am I doing for time? I'm okay. So you should be excited about that. I am. What I want to show you right now, just real quick to put this into context, is to look briefly at data life cycles and how it relates to the ethical implications of repurposing data. What I have here and diagrammed in front of you is a basic clinical trial. Somebody comes up with a research idea. It eventually finds its way in the form of a protocol to the IRB. They approve, they modify, they say, no, this is too dangerous, or they accept it. That also generates something called the Informed Consent Form, or ICF, if you've worked in this field. And that document is handed to the subject, the patient, and it discloses all the risks. So once we pass that point, we know as an institution, as researchers, that we're okay with this. It's been looked at, it's been cared for. We move forward and do what we do. So the ethics, there's a filter that's built in there. It's a system, a watchdog system to make sure nothing happens that shocks the conscience, to borrow a phrase from law. We conduct the study, and then you end up with study results. Those study results are used for the publication, and then that's it. They go into a filing cabinet. So it used to be literally hard copies went into filing cabinets. If they get used again, it's for meta-analysis, but it's still within the same, essentially the same research question, and then again, it's done. There's data science. Take the same data, send it off de-identified, anonymized, and then our graduate students take this and create incredible things, incredible devices like the one I held up. So one of the things that we need to perceive when we're talking about ethics is that at this level, there is no IRB review and there is no more informed consent. There's no reason to panic. That's not a problem. IRB exists to protect patients, to stop us from doing dangerous things to patients. At this point, there is no longer a human subject. It's all numbers, it's data. No one is going to get hurt. It is impossible. Now, the question of the informed consent, let's just go back real quickly, is a more complicated question. That's the question of, well, let's do this. So this boils down to two new ethical issues, or newish ethical issues. And one is, can you use it? Do you have the right to use or repurpose this data? And that's really a collection issue. And then how should you use it? Should you do this at all? That's the end product. The question of can you use it is the controlling document there is going to be the Informed Consent Form, or the ICF. We have Susie Hoffman here today, who is the director of the IRB in the back. Hope I got your title right. And she is the one who tells you whether your ICF is acceptable or not. And what they're looking for is to make sure that all the rights are being disclosed appropriately. And the big question for data scientists is, did that ICF say, hey, you can use this later? Or if it says, we're going to burn your data and bury it 6 feet under, well, then you can't reuse it. This becomes an extremely complex analysis for lawyers because the textual analysis is complicated. They were written differently. And we would be here forever talking about this. I would enjoy it, and the one other lawyer in this room would enjoy it, but you would not. So the question then becomes, and I'll wrap up here, should you use it? And this is going to, I think, Jared's point is going to be that it's not just a question of creating the technical expertise that all of you are learning, but also building in some training and some education about ethics, because you are going to be the ones deciding whether or not something should be done. So let's look at some examples here that I wrote out. You can take clinical trial results the way I just described to you, and you can repurpose them to incredible life-saving devices. I think I've just shown you the artificial pancreas. You can make things. You know, children, particularly juvenile patients, their blood sugar can drop in the middle of the night, so parents have to stay up and go test their child's blood sugar. This device, if it keeps it stable with a closed-loop algorithm, they don't have to do that. The child is safe. And people can literally die from that. You know, I think we would agree that that is an ethical use of this data. We certainly have to have permission for it. But as all of you know, from various, like if you click on Facebook and there's some creepy ad about what type of socks you want to buy, and it's because you were thinking about them and somehow, you know, Amazon got inside your head. There are even more scary ways to do this. There's one that I just sort of thought up here is, what if we were to take a massive amount of brain scans? IBM Watson actually does this to help identify lesions. What if you were to use that to compare that against the brain scans of people who had done something criminal, murderers, mass murderers, and then you establish that there's a difference? Can we then take that and extrapolate backwards that because somebody's brain is one way or another, that means they're a dangerous person? Now, as a lawyer, who is oftentimes, in my former career as a trial lawyer, I'm called upon to prove a point. I'm going to push the envelope because that's my job, and it's your job to stop me. So if the jury is there and thinking to themselves, I'm not sure if this guy really did the murder or not, and then I show you a brain scan and say, see, I told you so. This guy's 70% likely to have committed a murder. I guarantee you, as a prosecutor, would try to use it that way. We need to be asking ourselves, is that acceptable? As scientists, you may say, yeah, Phil, don't worry about it. That's bad science. Trust me, go into a courtroom sometime. You will see bad science all over the place. In fact, you may be contacted by a lawyer to be an expert witness to do just such a thing. I hope you don't. So in the end, the acquisition is a complicated legal issue, not enough time today. But I think for Jared's purpose, this idea of understanding how we're doing this and how you should be doing it, how you should be approaching the work that you do is the key issue that I wanted to bring. So thank you very much. This is my department. We're a sponsor, the ACDT. Thank you for your time. I'll give up the floor.
So I'm Stephanie Shipp, and I'm with the Biocomplexity Institute and Initiative. We're new to the University of Virginia, just about 11 months old at this point. Our scientists conduct research that ranges or spans from bench biology at the molecular level and scales to societies and populations driving towards evidence-based policy. And based on the name of our division, we are at the societies and populations side of this initiative. I want to talk today about challenges, ethical challenges you face in the all-data revolution. And I'm going to start with the first challenge and align it with the metaphor, the Panopticon prison. Today we can observe behavior without the consent of the people providing the data. And this is similar to this prison in which it's built in a way, it's a circular building, and it's built so that prisoners cannot see who's observing them. So the intent behind this was it was meant to encourage good behavior on the part of the prisoners. And the intent in this all-data revolution is that we're assuming good intent by our researchers as well, who are using these repurposed data. So the idea is that we need a broader view of ethics that adapts to the spirit as well as the rules. But what we don't want to do is restrict access to data by the researchers. Instead, it would be better to punish misuse, which if we can design our systems in a way similar to this type of prison, we should be able to do that in a way that we can observe bad behavior but encourage and reward positive behavior to use these data in an ethical way. So a second challenge, and probably one of the more underlying challenges in all the work we do, is detection of implicit biases. And this is a fairly old example, but I think a compelling one that talks about how Amazon used algorithms to predict where they should have same-day delivery. They didn't use race in their algorithms, but we might argue that perhaps they should have. The data mapped almost perfectly that same-day delivery would occur in areas in white neighborhoods and not in neighborhoods with underrepresented minorities. So the data or the algorithms actually picked up the social biases that are inherent in the data and in how we approach developing our algorithms. In a second example, there was a large hospital, and they create, well, all hospitals, insurance companies create risk scores for patients. And these risk scores, or these algorithms, were based on medical claims and medical billings. Well, underrepresented minorities are more likely to not use healthcare or access healthcare services. So if you base these algorithms based on medical billing, they're going to receive much lower risk scores than do the white population. So actually in this case, well, and actually in both cases, researchers independently tested these algorithms to figure out why there appeared to be some implicit biases in them. And to the credit, what they did was they used actual health records to predict what these risk scores should be, and they were able to reduce the implicit bias by about 84%. So they couldn't entirely eliminate it, but they could reduce it significantly. So to both credit Amazon and to credit this large hospital, they did change their algorithms in response to this research. So in our research group, we have developed a data science framework, and we've done this by working many problems, primarily with local, state, and federal government, but also some industry examples as well, or industry problems. We have, in the last year, begun to build ethics into every facet of our research, and we do this through active dialogue, through questioning and discussion. And as a result of this, we realized that there are no rules when it comes to repurposing data, and that you have to take a principles-based approach to conducting research when you're doing this. And this involves, of course, responsibility and methods and documentation of these methods to be clear in the approaches that we're taking to address ethics at every stage of our research. So let me just give you a little bit of history. The Belmont Commission was formed in 1978, and it was formed because there had been many ethical failures over the last 40 years. Perhaps the most famous was the Tuskegee syphilis study. And out of this commission, they developed 3 principles. These principles are that you have to have respect for persons, you have to recognize individuals as autonomous and honor their wishes, their individual wishes. Beneficence means that you need to weigh and balance first the criteria of do no harm, but then balancing that with maximizing benefit while minimizing harm as well. And then justice is you need to look at the distribution of benefits and risks and make sure that they are fairly distributed. So these three principles were codified into law, and this law now governs all of US federally funded research, and it's manifested itself or instantiated in our Institutional Review Board or our IRB processes. And importantly, I want to note that it focuses on the research involving human subjects. So those people that are involved in the study are those people for whose data that you're using. We're going to differentiate that. In 2012, the Department of Homeland Security commissioned the Menlo Commission to bring the Belmont principles to the computer science field, to the information communications and technology people, or to people in that discipline. Importantly, though, what they did was they expanded the Belmont principles in really important ways. The first they did was to add a fourth principle, respect for law and public interest, which means you're not just focusing on human subjects, but you're expanding it to all stakeholders. And their focus, they also broadened it to encompass research with human harming potential. So now you're talking about how does your research benefit or harm society, not just the subjects in your study. So the focus of the IRB is on the people, the subjects in your study. The Menlo report advocates a broader approach to ethics in our research and in our data science research. And so we actually believe that we should embrace this, even if not required to, by the IRB, and we believe that data scientists can lead the way in doing this. So what kinds of things are we doing? How did we begin to establish incorporating ethics throughout our curriculum and throughout our research life cycle? The first thing we did was we had discussions about what criteria we wanted to use to ensure that we were implementing ethical principles throughout our research. And then we did this by discussing what kinds of implicit biases could occur and how we would question and discuss this throughout our research life cycle. And almost all our professional societies now have ethical statements, and they provide really good guidance for how you might get started, what your criteria might be, and what kind of questions you might ask throughout this process. And finally, and we just keep reiterating this, we want to ensure that documentation, transparency, ongoing discussion, questioning, and importantly, constructive criticism throughout our curriculum and throughout the research life cycle. I think one of the really important points that came through with the examples was that you want to continually validate your results and do your internal reviews, but that external review is really critical as well. And sometimes that happens independently of you reaching out. It also it needs to incorporate inviting external reviewers to review your work as well. So we have an ethics checklist that we use to get started with our data science projects. We began to implement this last summer through our Data Science for the Public Good Young Scholars Program. And one of the very first questions these students asked, if we're using public data, why do we need to consider ethics? Well, of course we need to consider ethics. It doesn't matter if the data are publicly available or not. It's, as the Amazon and the hospital risk scores demonstrated, implicit bias is built in, can very easily manifest itself through our research. But I think an example may be compelling. They were undertaking a study with Fairfax County, and they were creating vulnerability indexes. And they made the assumption that if your household had a septic system and well water, that you were invulnerable. Well, this is where the importance of context comes into both the ethical review as well as the analysis of your research. In Fairfax County, if you have well water and a septic system, you're likely to live in some of the largest and wealthiest homes in the county. And so understanding that context more broadly is really important in terms of how we validate our research results and take into account the ethical dimensions of our research. And I see a few of you sort of laughing at that because maybe you relate to that as well in the Charlottesville area. So, thank you.
Stephanie introduced me as an anthropologist, which I am, but I'm also a philosopher. And as a philosopher, I do not do PowerPoints. So this is I'm already uncomfortable, as we see. You're also going to see you're going to contrast the sparseness of what I put up here with what we've seen so far. And perhaps that'll also, in a sense, mirror the way I'm going to step back a little bit. And I will hope to not talk in a way that is too boring for the room, in the sense of being too abstract and distanced. We'll see. But today I want to talk just a bit about ethics. Let's see if this button works now. I don't even know where you put it. Yeah. So far we've heard a good bit about what I would call research ethics, which is oftentimes associated with the Institutional Review Board. And as we've already kind of had an indication of, and as many of you probably in the room already know, basically everyone in academia who does research with human subjects has to get IRB approval first. So that's whether you're doing ethnography, as anthropologists do, some kind of medical research, or psychological experiments. And among other things, this is meant to protect anonymity, data security, and risk. So there's a lot of talk in data science these days about such things, as we've already heard. And while there's definitely some work to be done in terms of adjusting to what already exists to fit the questions and the issues raised in data science, I would say that we already have a good place to start. And so I oftentimes read things or hear people talking about these great new things that they're going to invent to do ethical reviews for data science. And I think, well, why do we need to reinvent the wheel? We just need to make a better and more appropriate wheel. So that's just a little plug for following up on what we already have. However, I don't really want to talk about that, because for the most part, I'm rather critical of the IRB. And I think it's a grave mistake to equate ethics with research ethics. I put this simply in parentheses, just in a sense to be kind. While there's no doubt that research ethics does important things in terms of protecting research subjects and similar things, we also need to be honest with one another that a great deal of what research ethics does is protect institutions from litigation and similar things. So if we want to call that ethics, then I would say there's at least a 2,500-year history of the Western tradition of thinking of ethics that would think that that's not ethics, or it's not what ethics is simply about. So now I'm going to play the philosopher role. We always love to go to the Greeks. As I said, this has been going on for 2,500 years at least in the so-called Western tradition, and it's very likely as old as it is as the human species, to ask the question of who we are, how we live together, and what we want our worlds to look like. Ethics comes from the ancient Greek ethos, which could best be translated as habit or disposition or character. And its original meaning meant accustomed place. So in contrast to the ways in which we often hear ethics put in terms of principles or rules or guidelines or checklists, in fact, ethics, for most of the history of Western philosophy, has been about what we might call an embodied sensibility, a lifelong training of how to live well with one another and ourselves. And also when we think of it in terms of accustomed place, ethics is situated, it's social, and most importantly, it's relational. For 20 years, I've been developing a theory of ethics that I call relational ethics, which, you can read the books, you can read the articles, but let's put put it in a few words, it's about the establishment, maintenance, and care of relationships. This is founded in the longer tradition of ethics, as I had it up there a moment ago. Can we go back? Yeah, we can go back. Look at that. No, we can't. Technology. Fantastic. In this longer tradition of ethics as embodied sensibility that is relational and situated. Now, I missed the part that I wanted to point out, that this view of ethics was dominant in the so-called Western tradition for over 2,000 years. It was only about 500 years ago, and for philosophers, that's the beginning of modern philosophy. So that's almost contemporary. It was only about 500 years ago, after René Descartes and others started talking about rationalism and were developing a philosophy in the defense of and to create a foundation for science and mathematics, that ethics slowly started moving in the direction of talking about laws and rules and principles. And it was only in the 19th century, once capitalism finally became a dominant form of economics in the West, that ethics started to be talked about in terms of use and utility. And so today you can see how those two have combined in a world that is primarily dominated by science and capitalism, as ethics as instrumentality. And that's when we start talking about ethics as problem solving, research and business ethics. Ethics is a problem that can be solved. So that's the longer history lesson. In response to that, philosophers today, and I'm one of them, have been, in a sense, going back to the Greeks for inspiration to revive ethics. And this is what I call a relational ethics, where ethics is about establishing, maintaining, and caring of relationships. That means ethics is an ongoing process. There's no rule, there's no principle, there's no matrix to follow. We can't go into the coffee room and look at the principles on the list, on the wall, and say, oh yeah, good, I'm following all 10 of those, I'm ethical. Ethics is an ongoing process of attuning to one another and caring and maintaining for our relationships. Therefore, we don't have rules and principles, but what we do is we attune to one another. We try to dwell together. We try to care for one another and ourselves. We try to invoke a world of justice, and sometimes things break down, and we have to do all of that over again. So I have an article coming out in January where I make the case that one of the primary objectives of what we might call data ethics would be to cultivate what I've called empathic attunement. You can just think of that as empathy if you like. And the case that I use in that article is a case that you can read about in a book called We Are Data, where Mark Hemmings, a man with disabilities in England, called essentially the English version of 911. He was in severe pain, needed an ambulance. The 911 operator answered, asked him several questions to see if he should get an ambulance. It was determined that he should not get an ambulance. It was not the human operator asking questions. It was the human operator asking questions that an algorithmic triage system was telling her to ask. 2 days later, Mark Hemmings was found passed out on the floor of his home by a care worker. He was then rushed to the hospital in an ambulance where he died. He had a gallstone. If the algorithmic triage system would have simply sent him an ambulance, that would have been a simple operation and he'd be alive today, and I would have had to give you another example. This famous human in the loop that normative data ethicists always talk about was in this case rendered non-human. She was simply a voice of the algorithm. An algorithmic triage system that was implemented, very likely based on the primary value of neoliberal economics, looking for efficiency and money saving, rendered the human non-human, and simply the voice of the algorithm. The human in the loop does not exist unless we allow it to exist. What this case suggests is that, at the very least, there's a necessity of what I call empathic attunement. You can just call it empathy if you like, that needs to be somehow built into such algorithmic systems and cultivated in data scientists. How do we do that? Data ethics education is not simply ethics of big data. We should definitely teach that course, but we should teach a lot more. It's not about teaching future data scientists to follow the 10 principles that we put up in the coffee room. It's about, I don't even know where. There we go. It's about cultivating ethical sensibility. Data science students need a robust and well-rounded education in ethics that includes ethical theory, but also social and cross-cultural education, so as never to believe that what your society thinks and says is right is the only option. We also need to learn about history, and literature has always been a great resource for thinking about and becoming ethical. So the future ethical data scientist will not be a rule follower or a principle adherent, but an ethically attuned person who also does data science. Thanks.
All right. You heard from 3 diverse speakers. I think we all had a similar message. We purposely ended with Jarrett to broaden this notion of ethics. I think it comes back to this point of taking a principled approach to it and looking at problems more broadly as well. And I think the human in the loop and bringing in the other dimensions are critical. So we'd like to open it up to the audience, and keeping in mind that the Data Science School has also asked for ideas for how they will incorporate ethics into their approach to what they're doing as well.
If you don't ask questions, I've already picked out some of you who I'm going to call on.
Okay.
Can I do that? Or do we have a question up?
That's for Jared. It's philosophical in nature, but how would you handle the objection?
Can you stand up and introduce yourself?
I'm Joe.
And maybe project a little bit more.
Yeah, sorry, I'm trying to.
Sorry.
As I can. In the example you gave of Mark Hemmings with the ambulance, how would you handle the objection of, maybe it's not a cost-saving measure, but what if there are just limited ambulances? If the ambulance didn't go to Mark Hemmings, or if it did go to him, maybe it couldn't go to somebody else. How would you handle that objection?
Right. So that, when I said that, that was based on the example that I read in the book, where the person writes a full chapter and plus about this case and has done quite a bit of research on the issue. So in at least how I understand the case, and again, I'm getting it from this other book, is that this system was put in place as a money-saving budget implementation and not about resources of ambulance availability. I'm not going to address the hypothetical because at least in this case, it's not really the case, as far as I understand it.
Hey, I'm Dean. I'm the other lawyer in the room. So, part of this is that law is sort of an attempt to encode ethics and make it enforceable, but it's often doesn't really do a good job of that. So how can we either do a better job of making sure that the law keeps up with the ethics that are aspirational, or how do we turn sort of the aspirations of ethics that are not encoded in the law into something that people are going to follow without sort of having the ability to punish them?
Do
you want to comment?
You're the lawyer.
So, fabulous idea. One of the things that I would respond is that as soon as you attempt to codify a set of rules, there's some sneaky bugger like me who's going to try to find a way around that set of rules. I don't actually do that, but that as soon as you write down, it's like a kid. They're going to find an exception to the rule that you just made. And so codification, while it's a wonderful thing to do, it also it defeats flexibility. The flexibility to think in a situation, which I believe is really kind of the core concept you were talking about. Give me better words, but to have somebody who's able to critically think in the moment.
Situational sensitivity.
Yeah. So, Dean, you and I both know from our living that it's not just about that there's edges and margins to everything. I mean, wouldn't you find that? Don't you agree?
Yeah, I mean, what I do a lot of times, what makes my job hard is I'm going. What I really want to do is go beyond what the law would require to require people through other means, contracts and things like that, to do what we otherwise couldn't make them do. But there's not always an option to sort of compel people to do that.
Yeah.
Oftentimes you have to try to appeal to people's better nature or a sense of something larger, which is in a lot of ways a lot softer than having the ability to tell that they have to for one reason or another. Otherwise they'll face some sort of penalty.
Yes. It was my experience as well while practicing law.
Before Stephanie goes, I just want to point out that in case we're keeping score, Phil has now referred to lawyers as children and using bad science.
And I believe I said sneaky buggers too.
And then sneaky buggers. Yes.
Don't send your kids to law school.
Well, that way you have to love him because he's already said all the bad things about himself. Back there?
Yeah, my name is Doug. I have a question for Phil. I think that your cost of zero for the getting this data, I mean, doesn't seem quite right because I assume that you charge money to do the agreements and there's money associated with storing the data, and so
There
just
is.
wondering what it's less costly than generating your own data. But there is a cost to gathering.
You're absolutely right. Yeah. So if it would take $500,000 to collect that data yourself, then the actual cost would be the salary of the staff and So yeah, you're absolutely right. The project is going to cost money, but the data collection has already been done. So technically zero is not correct.
Yes?
Joe Michaleski. So
Joe.
you sent me
Yes.
an email. So
Glad you're here. Would you introduce yourself and what your role is?
So I'm an associate professor in public health sciences and Center for Public Health Genomics, but very recently I also took on the role of assistant dean of biomedical data science research in the School of Medicine. So your slide where you showed the data sets and no kind of IRB or consent applicability to the secondary use of those data sets
Yes.
is perhaps a little bit disingenuous. That's not quite true at the moment, in the sense that informed consent still is sort of in controlling or overseeing the use of that data.
Absolutely.
Maybe what you're talking about is maybe a future world where we sort of have, at some point, a participant no longer has the ability to sort of make any determination about what their data is used for in future. And that's clearly where I think the funding agencies are sort of moving to, in the sense that we don't want these sort of looking forward, these sort of feed forward informed consents, that we actually want to try to open this data up as much as possible.
Absolutely, and that my diagrams are limited in their representation. All I was going for was the idea that you don't have a reconsenting process at that point, and therefore you are referring back to the original ICF. And for example, the new common rule now has language that's much tighter that provides for the type of open use of that data and does a better job of advising the subject. But yeah, no, absolutely.
And I think one of the problems, though, is that thinking about all the uses that can be made of data now and trying to put that into a consent so that an individual can sort of go down the list and say, I want it used for this, or I don't want it used for this purpose or this purpose. It's almost impossible to sort of comprehend to sort of think about all those possibilities.
So there's two gentlemen sitting in front of you, Jack and John, are graduate students, and in the next 20 minutes, they're going to think of 5 different ideas of what they could do with a data set, and it's literally changing over and over again. Am I right? Is that, yeah. And for exactly that reason, so you need to have some broad language that advises people that your de-identified data could be used in any variable number of ways. But I do agree with you, we have a serious obligation to make sure people understand that it's being used that way. Historically, the ICFs weren't terribly precise about that because we didn't know what Jack and John are going to be doing. It's so new. So we're getting better at it.
So I do actually have a question to follow up on that, because I was curious why you would not submit a new IRB, though, when you are repurposing data. We do, because your research questions and how you're using that data, to me, would need to be vetted each time.
Susie Hoffman, may I call you to help out and introduce yourself and who you are? And
Susie Hoffman, I'm the director of the biomedical IRB here at UVA. Can you hear me?
yes. Yes.
So the way the common rule is written, is this on? The way the common rule is, or 45 CFR 46 is written, is that if data is de-identified, and they have a definition for that it's not considered a living human subject. Therefore, IRB rules don't take effect. Where there's a slightly different interpretation is the FDA regs, so that if you're using specimens that came from a human being, they're still considered a human subject. And so you'd have to follow the FDA regs about protecting human subjects and not the common rule regulations. Did that answer your question?
Yes, I think it does. And do you feel, Jarrett mentioned that the need for continued review of, for example, in the data science project, let's assume it's 100% de-identified data, it doesn't trigger any of your technical rules. How do you feel about the possibility of that scientist submitting it to a review board? Do you think it's a good idea?
Well, so under the current regulations as they're written, for the most part under common rule, we would not need to see it.
Right.
Although I will say that when the common rule was rewritten and went into effect this year, most of it, they said that they're going to reanalyze the definition of de-identified every few years.
Mm-hmm.
And I think the first version of that new definition is supposed to come out in January. So we'll have to wait and see what's going to come out of that. Because they realize that science is changing.
How do you feel about doubling your workload?
Well, it's what we need to do. So. Yes.
Yeah, you've been wanting to ask a question?
What does the specimen mean? So, right. So let's just say you're developing a new diagnostic device. So you're going to measure blood levels of something. So if you're using a specimen that came from a human being in developing, right, biological specimen, and you're going to submit that data to the FDA, then that specimen is considered a human subject, and you have to follow the FDA regs.
Joe, can I ask you a question? What if somebody were to come up with a research idea that we, society, the university, were uncomfortable with the nature of that research, and that it was de-identified data being repurposed? Do you think that there are guardrails in place, or how would we manage that as an institution?
Are you talking about risk to reputation, EVA reputation?
Well, that's there, but I'm actually thinking more along the lines of something we think would be unethical, like the idea that I mentioned, misusing brain scans or doing something that we just think shocks the conscience. Genetic manipulations, CRISP is not directly on point, but you know, how do we manage that? I beg your pardon?
It would be reviewed. I mean, is that
But if it were strictly data science, what if it didn't trigger IRB review?
Here you are, sir.
Thank you. So either the participant is dead, as Susie said, or if the participant in the original study is still alive, right? And then the data that was generated under that original protocol would have had some data sharing aspect of the protocol, right?
Yes.
And if the data sharing was, so let's say the participant signed a consent that said you can use this for anything. I mean, that would be the most permissive case. That would be no problem for you, but then I think it then gets into these issues of ethically, above and beyond, you know, what the participant legally signed to, and in terms of the ethical requirements that we have in research, is it still right to do? Is that what you're asking?
I misunderstood your question to me. Yes, not necessarily the reputation of the university, but the university's obligation as you know, we're responsible for making sure we do ethical things. So yes, how do we manage a situation if?
I mean, I don't. Yeah, please do.
So, no, you're fine. So one of the processes we have in place for studies that come to the IRB is that the IRB can approve a study, but the overall institution can disapprove it.
Yeah.
It can't happen the other way around. So actually all of our agenda for our meetings, all of our studies are sent to administration and they can review it, and if they're uncomfortable with a particular study, they can disapprove it.
We okay
All
with
right.
that? Yeah.
You want to respond? Okay.
The last wedge of that question is if it is 100% de-identified data, strictly data science doesn't have to take a tour through the IRB. Should we have some system in place that is making sure that whatever science I'm doing, we don't find abhorrent?
Isn't that the point of the checklist?
It is part of the checklist, and while in one sense a checklist makes it sound like it's easy and I just need to check, in fact the checklist is a guide to have these discussions to achieve what I think Jarrett was saying is this situational sensibility. So I'd like to broaden the discussion a bit, not that the IRB isn't important, but I think it's a process that we all know and love, or maybe we don't know and we should learn about, depending on what your discipline is, and we alluded to that a bit. But when I gave an earlier version of this talk, I had somebody from industry stand up, and they said, how do we teach our students to think ethically? We want students that come to industry who will have the situational sensibility, who will question what we're doing and actually ask these hard questions and ensure that companies are taking socially responsible steps toward whatever it is their research is undertaking, their questions. So I'd love to hear from the audience about how we broaden that. How do we do that? And I think that's exactly what the School of Data Science is also looking for. And I know in our research group, that's what we're trying to achieve as well. How do we set these students forth to be ethically good workers in the workplace? Yes.
The name is Rana Ganguly. I work for the College of Arts and Sciences, and I look after sponsored research development. Jared mentioned, he talked about relational ethics, right? So this would seem to suggest that ethics can be different across scales of time and space. So what may seem ethical to scientists here in the US may not be ethical to people in China. For instance, if you take the recent case of genetically manipulating and giving birth to a baby using CRISPR technology, a near-perfect baby, and there are ramifications of that. So given that research, and in particular data-driven research, is very international, or rather global, and it's not only in terms of sourcing data, which can be international, but also research teams can be international. So how do you navigate these ethics-related issues without a common universal code? So is there some move underway to also start a discussion across nations and arrive at a common code, which of course will not be steady because this is a very dynamic sort of entity, so it will keep changing with time and space and as there are more developments. But there needs to be at least some kind of a common agreement which governs future research. So can you please enlighten us a bit about what's happening there?
Jarrett, do you want to start with the relational ethics?
Yeah. I don't want to. Can you hear me? I don't know
Yep.
if this is working. Yeah. So I don't. Rana, in a sense, brought up the question of relativism, which and so I don't want to get into again something that's more abstract than it has to be. But I would just say that by relational ethics, I don't mean a relativist ethics, and what I do mean is something. I also don't mean a universal ethics, and again, let's not get too philosophical. But what I mean specifically is a situational ethics, and situations arise differently, whether it's in China, here, or down the street. Every moment we're faced with new situations that we need to attune to. So in that sense, I'm going to refer to what I was saying earlier. I agree with probably everyone in this room that there has to be standards of how we do research, the kinds of projects we want to do, the kinds of projects that we wouldn't want to do. If you want to call that ethics, then that's fine, but that's not what most philosophers and people who do ethics would call ethics. I find that to be a really important distinction to make. In terms of how we want to begin to address how we would start to make the kinds of conditions for research and projects that Rana was asking about, I would want to go back to what I was pointing out at the end of my talk in terms of education for data scientists, which Stephanie was trying to get us to address. So we're starting this new school of data science here, and one of the things that we're doing is trying to figure out what the curriculum looks like. And what I've been really pushing is that all students should take a third of their credits in ethics broadly construed, the kinds of things that I had up on my last slide. This maybe at first sounds quite crazy to some people, but in fact it's quite normal if you look at disciplines across the university, where almost every major has to take about a third of their classes in these kind of gen ed type of classes, which are primarily in the social sciences and humanities. So this is true whether you're a philosophy major, or if you're a biology major or an engineering major. This gives you a very broad background in ethics, literature, history, cross-cultural thinking. And while certainly this isn't a guarantee that someone's going to come out on the back end as a more ethically sensible or sensitive person, I think this will go a long way to showing the complexity of just the kinds of issues that Rana raised that can't be simply addressed by through a kind of instrumental reasoning or a profit margin reasoning or something along these lines.
Phil, did you want to add something to
I think you covered it.
We're good. Okay. I did see a few more hands, and actually one more question, if there is one. I'm going to use this then as an opportunity. We did bring copies of the guide that we use and how we're beginning to develop this and work with students in our projects. So if you're interested, our director, Sally Keller, is sitting here as well, and we would welcome conversations with you about this as well, how we instill this into a liberal arts education and how this becomes part of the sensibilities of our students as well as our faculty and researchers. So thank you very much. This was a great session, and I've really enjoyed working with you both to develop this.